Okay, hi everyone. I'm Chiara, and I'm co-founder of VitreaLab, where we created the future of displays. So we are a hardware startup based in Vienna and shaped by top-level engineers. So what are the major problems of current displays? First, obviously, energy efficiency. As you might know, the components which consumes most of the batteries of our smartphones and laptops, it's the display itself. And secondly, why are we still not having a full 3D display, which shows images coming out from the display in a fully 3D immersive experience? This is still related to energy efficiency. The key to understand this problem is actually light control. So the only way to move forward is by using laser light, which is a very specific type of light which can be controlled, shaped very precisely, guided through a certain direction without dissipating all around, like the old bulb lamps. In VitreaLab, we have a solution which is based on the laser lit chip. This is an illumination device which controls laser light very precisely at the microscopic level inside a thin glass plate. Through the glass, the light then is emitted in the form of millions of laser beams in red, green, and blue color. Here you see one of the latest demos that we have already shipped to partners, where the laser lit chip is combined with the other components of the display to create an image. And if you zoom in the image, you can see that at the pixel level, the image is created with red, green, and blue laser beams. So what are the advantages of using our tech with respect to competitors? So first, obviously, a huge boost in energy efficiency while keeping low the cost of the product. But on top of this, we can also enhance the brightness. This means the sunlight readability of smartphones and laptops. Additionally, we can improve the color quality, and last but not least, in future, we can create fully 3D images. So this means that the market is actually covering different categories of the displays. So I mentioned the smartphones, that's a long-term vision for energy efficiency, but in the near term, we are actually targeting more niche markets, like, for example, medical displays, where there, for example, the color quality of the image is really important to help guide surgeons during their operations. They really need like nice, sharp images. Or, for example, augmented reality glasses, where the light which comes through to the eyes through your glasses has to be very, very bright and in a small, compact form. And that's what we can do with our laser lit chip. So currently, we are finalizing our prototype to show all these major advantages with our tech. In 2 years, we expect to have defined a pilot line for mass manufacturing, and in 4 years, to have a first product design agreed with one of our partners. The business model is obviously technology licensing, so we are continuously expanding our IP portfolio. And the core of the team, so obviously the core of the company is the team, so we have by now 8 photonics engineers coming from all over Europe to Vienna to work in our facilities. And today we are raising a round of 3 million euros, which will help us to progress our tech and obviously achieve the first big collaboration with one of our partners. With this, I thank you for the attention. I'm happy to reply to any of your questions.
Thank you. Questions?
I have a question. First of all, thank you very much. It's impressive technology. First, the question on the cost. You said you're less costly than other displays. I'm assuming you mean when you're reaching manufacturing scale as they reached for the other ones.
Yeah, exactly.
Okay. And then from Gen 1 to Gen 3, where you actually have a thing you can use on a smartphone or tablet or something like that, what milestones do you need to achieve to do that? So on the TRL level, where are you there currently?
So can I go back? So it really depends on the categories of the display product that we are tackling. For the smartphones, since the pixel resolution is quite important, we still need to develop further the process itself, or how we create this channel within the glass to control light. So this means its process development needs a little bit more progress and advancement. So it will take like 2 years to get the full prototype for the smartphone case, and then go to the big display manufacturers and sell the license. In the other case, for AR, the manufacturing, and for also the medical displays application, the manufacturing is much more simple. So we have already starting projects with them, which shows the first key, like the potential of the tech, and they should be much easier and faster going to the market. So that's why we expect in 2 years to have already the product defined with the partner and being in the market and being mass manufacturable in those niche markets.
Thank you.
We have time for one question if there's a...
Do you have visibility of where your competitors are in the life cycle of their products developing things like this?
Yeah, so the biggest company are actually mainly using standard techs, which have been developed since many years, and there is not really a potential huge advantage on those. And in certain categories, it's really impossible to move on with the current technologies. So it's really hard to have competitors with the standard technologies, because they have been working on these problems since 20 years, for example, for creating holographic displays. And there was a huge boom 20 years ago already that they wanted to sell in many startups, but no success. So it's really hard.
Thank you.
You're welcome.